morning. Can you hear me?
Yes, I can hear you well. Can you hear me?
Yeah, I can hear you. And 11:35, you go live. Okay. Lavina, you are here.
Yes, I'm here. When do I have to start? What is this Central
Yeah.
European
I'm
time
just
here?
telling you. Just hear me out. We have a moderator here, Lavina. Okay. She would be
Yeah.
introducing you, and after that, you start sharp. We already have around 30 people waiting for you in the call. Okay.
Okay, so I have 13 minutes for my talk.
So the time slot is already with you. You know your time slot. All I'm telling you is that okay.
Thank you.
Yeah. So 11:35 you can start, and right now more than 30 people have already joined you. You can see on the top, and you would be receiving questions on the chat. Okay.
So you give me a sign when I have to start my presentation.
Yeah, I will. I'm with you. Don't worry.
Says, thank you, thank you.
Yeah. Stay connected.
Okay, I stay.
Hi, Lavina.
I'm not able to change the background. Should I have the same information background?
Lavina, can you hear me?
Yes, I can hear you.
No.
Hello, hello, I can hear
Yeah,
you.
no, sir. I'm not talking to you. I'm just talking to the moderator.
Okay,
Who is there.
okay,
I'll
okay.
give you a clue. Don't worry. Lavina, you are here.
Yes, I'm here.
So, Lavina, I think we are just 1 minute away. You can start the introduction. You can on your camera.
1 second. I just wanted to check if I can change my background.
You cannot. You cannot. You are not in Zoom. Please don't change that.
Okay, fine. So then do I need to sit in another place? 1 second. 1 second. ये background नहीं change होगा. वहीं बैठती हूँ वो wall पे, ठीक है?
Guys, we are in the live mode. Lavina, may I request you? Yes. Jyoti, there are already 40 people waiting for his presentation. No need for him. He can start it. I will just tell him. I will give him a clue. Okay. Yeah. मैं कह रहा हूँ जरूरत नहीं है उनको लवीना को इसमें आने की. ऑलरेडी 11:35 हो गया. I can ask him to start. Already 40 plus people are there who are waiting. Yeah. Okay, I'm just asking him to start. Okay. Sir, please go ahead and start your presentation.
Okay, that's me, Michael. Hello, everybody. Can you see my screen, my presentation?
Yes, we can, sir. Please go ahead.
Okay. So hello, everybody. The next 30 minutes, I will give you our presentation from the company HBK, which is located in Europe. Our topic today is what can we do to get our production smart, and what are the points to save time and money. Some few words about me. My name is Michael Guckes. You can see my picture. I'm working for more than 20 years in the company as a product manager for industrial electronics and smart measurement solutions. I've studied this also in past time, and I will start my presentation now. This is the topics which I will hit today. So as our company is doing sensors, electronics, and software, we concentrate on these products and what they can bring us to a smart factory. What are the benefits we can get out of these measurement change, and what are these so-called smart functions? I will show you also a little live demo a little bit later on. And in the end, I will show you what are the technology, what are the future developments which we can reach out. And I also have a short explanation and a short example of a smart factory. How does it look today and how will it look in the future? So this is actually here our playground. Means these are the industries where we see a typical production or a condition monitoring. You see the main industry, automotive, wind energy, medical, machine control, test stands, etc., functional testing. So this is where all our equipment, or we have to measure these signals which we need to get the production line running efficient. And how can we raise efficiency and the outcome and drop down our costs and save money? I will show that. The first picture I brought today is what do we understand with communication 4.0. So in the early days, you remember, hopefully a telephone is more or less a telephone and maybe a little game on that.
Michael,
today we have, yes?
Michael, you have to share your presentation.
Hello?
You have to share your presentation, okay? You have to share your screen.
Sorry?
You have to share your screen, Michael, for the presentation.
I thought I did it. Sorry.
You share your screen once, the presentation, please.
Okay, wait a second.
No problem. Take your time.
I want to share the whole screen.
Yeah, you can share the whole screen or window, whatever is comfortable to you.
Okay, sorry for that. I want to click on this sharing button, and then I got a window which I want to share, but it's not. I can't click sharing at all.
Wait for a second. When you get a window, there is a window which is showing like whole screen or.
Yes, I'm there, and then on
click that.
I click on tile, means sharing, but it's light blue. I'm not allowed to click that. Sorry.
Wait for a second.
Maybe you can allow me as an admin that I can do that.
Wait for a second.
Yes.
So, Michael, if you can tell me, it is a HBK PDF file, correct?
Sorry, what file?
It's a Automation Expo Connect PDF file which you are gonna present. I mean HBK, by the name of HBK.
I have my PowerPoint here on my laptop, and I want to share this.
I can share on your behalf. I'm just confirming you. The PPT is get smart in your production and save time and money. Is it?
That's right. That's it.
Okay, I'm sharing that. Just hold for a second. Yeah, it is shared. Please go ahead.
Okay. Sorry for this little mistake. So I start again with our presentation. What is a smart what is a smart production and how can we save time and money. Please to the next slide. Can you switch to the next slide, please? Hello. Next slide, please.
Yes.
Okay, this is our agenda, which I want to introduce to you, ladies and gentlemen. Advantages of measuring chains, meaning where do we have to place sensors in our production to get it smart, and what means smart. And I also will show you a little example of a smart factory, how it works today. So please, the next slide. So this is actually where we are in. A lot of machine monitoring, assembly lines, wind energy and functional testing. Everywhere we have to use sensors to get a feedback from the production and also to optimize our production and to make it faster and more efficient, and so we can save money on our production. Next slide, please. This is a little example here how we see an evolution in communication technology from the very simple smartphones or cell phones in the past. Today we have smartphones available which do multifunctional operations, not only telephone but also pictures, camera, and also a connection to the internet. You know that, and we have seen this also in the evolution of a factory or even of sensing. So please, the next slide. This is what we got in the industry. So from 200 years ago, where we started with the first loom automation, then we have conveyor belts, then we have the third step in evolution with PLC programming, and today we are in the fourth step, and you see the times are shortened more and more, so step go faster, and on the y-axis you can see that the productivity is rising more and more. And now we will jump a little bit deeper how that affect our daily life in our production lines. Next slide, please. These are the information. These are the trends which we got from our customers and from the market. So the equipment has to measure more precise because we want to rise our quality, also in terms of a guarantee to our customers. The life cycles are getting shorter. The networks are getting closer. That means production and office are getting closer and closer together. We have to deliver dashboards. We have to deliver a permanent view on our production line to run it efficient and to jump in if we have some damages or if we have to do some services. So these are all things we have to consider if we plan our new factory line. Next slide, please. What can we do? First of all, as the sensors are the eyes of a factory line or of a machine monitoring, because here we get information as a feedback from the machine and how it's running. It makes sense to get it more precise, because you see that on the red bar, if the measurement uncertainty is getting smaller, we have less scrap, less standstill times, and we got more yield, more outcome, which means the green areas here in these pictures. So accuracy is one big point which we can use to rise our quality and to rise also our speed and the productivity of our production line. Next slide, please. What else can we do to make it easier? We have created a TEDS. TEDS means Transducer Electronic Data Sheet. This is a little chip here, which is in the sensor or in the plug of the sensor. And this makes it easy to connect the sensor to a measurement electronics, because the calibration data and the settings are on this chip. And as soon as you plug it to an amplifier who can read this information, the measurement chain is set and you can start your production. Also very easy if you want to make a service or you have to replace a sensor or you have to extend your production line. People don't have to be educated, just plug and measure. Next point, please. Next slide, please. Next point is that the quality which we offer, so it's accuracy, is also named and mentioned in a calibration certificate of the amplifier and the sensor, meaning the sensor has a storage inside, and with every device you also get a calibration certificate, which is really important if you have to show that to your end customer to guarantee that your production equipment is running in these accuracy classes and in these areas where you have calculated and constructed your production line. We see that there is a regulation from the government that you have to show on an audit the quality of your production line, and this can help you to your quality engineers to for the yearly audit to get this information to the quality officers and also to your end customers to be sure that you have a well-designed production line which is running properly. Next slide, please. Jumping a little bit now into the IoT, we see that the Industry 4.0 is only a part of the complete cake. IoT means essentially the Internet of Things, all things and devices connected to the Internet. On private, it's a smartphone, but on industrial, we have there actuators, sensors. We also have presses. We have all kind of actuators and sensors connected now to the industry. So these things, we call that IoT devices, but at the end, the Internet of the Industry 4.0 is only a part of the big cake of our world, and this is where we want to look now a little bit deeper. Latest, these things are connected somewhere now to a big data storage, can be a local one in the production line, or can be a PC or a cloud storage somewhere on the world. So this makes sense. We see that later on to store this data and to evaluate this data. By the way, I want also to answer some questions which join in here during the chat. The amplifiers you have seen, it's not an industrial PC, it's embedded electronics, but we have a microprocessor and a storage capacity and also a digital signal generator on it, so that it's much more than only a single amplifier. I will show you this a little bit later on, and you can see that in live. Next slide, please. So Internet of Things, some short explanations. What does that mean? We are coming from the sensor and the measuring amplifier, which are, let's say, the eye of our production. So we can look deep into to gain the data or the information there where we think. That can be a force measurement on a press. This can be let's say a speed measurement for a conveyor or whatever. So this we have to consider when we build our production line, put the sensors on the right places with the right accuracy. Next point is that we also have to use modern interfaces to connect it to a PLC or to connect it to a cloud. I will show that also in the next slides. And we have to see that these elements, these amplifiers which we have seen, which is as an example, the Guckes or the PMX system in our company, so that these give us also pre-calculated information. That means they are acting like a pocket calculator or like a little, let's say, PLC, giving us these informations to reduce a huge amount of data to that what is really necessary. Next slide, please. So this is actually what I mean. In the past, we had amplifier giving us an analog output, and then the machine builders have to see what they do with the signals, what do they calculate, what do they gain out of these signals. Today, these amplifiers are much more. I have talked about this transducer electronic data sheet. We have several technologies which we can measure: temperature, strain gauges, pressure, voltage, current, etc. We also have a heartbeat in it, so it's a live beat to see if the amplifier, the measuring chain, is still working. And we also have a lot of interfaces to a PLC. We have a web server for adjustment. So it's as you see, there are a lot of features to make the handling much easy, and also to have more additional functions, which you will see a little bit later on. So this helps us to save the money, and also in terms of service, to get a quick readout. What is happening in the sensor? Is it okay? Is it a broken cable? Is it a mismatch of my machine? Is the tool getting worse, etc.? So all these informations come out now of these amplifiers, of the smart electronics, which help us to catch the error very fast and also to save time. Next point, please. So I talked about smart functions. What is that? So you see, we have over the menu, over the web server, we have a functionality that we can use the signals and calculate with the signals. Very easy is a peak detections, but we also have several filters to filter the signals. We have counters, we have adders, multiplier, like a pocket calculator, up to PID controller, and so on and so on. That means the smart electronics here, they pick up their own sensor signal from the input, but they also can get over a bus several other inputs, or if it's a multi-channel device like above, you can calculate these signals like a summing force, a summing load, an average of a force, or a center of gravity. And this is real time. This is a difference if you do that in a cloud or if you do that in a PLC, because you have to transmit the data and then do the calculation. Here you have it in real time, means within 50 microseconds, so 20,000 samples per second or calculations per second are done in these smart amplifiers. And this edge computing makes it fast and reliable, that you have the best speed here to evaluate your production line. Next slide, please.
APML asset management.
So this is a little example here for a press application. You see we have several sensors here available, all connected and measured by these smart amplifiers. And within these application, we see that we can do a summing, and also we can do a calculation. Is a press perfectly centered in the middle, or is it somewhere running outside? Because then we have to check our press. There might be some problems with the mechanical construction. So you see, it's not only waiting until there is a damage. We also can do that service or maintenance as predictive task. Seeing that something is getting from green to yellow, we have to make a service before it's getting red, and we have to stop the machine. Yeah, and this is only one example. You can imagine this is for a lot of production machines very helpful. Next slide, please. This is just to make you aware that how these calculated channels or smart functions work. So there are blocks on the right side, where you, from the left side, put in your input signals. In the middle, you have some parameters for calculation. On the right side, you have your outcome, like summing, or in this case, you see here, it's a PID regulator. You don't have to write any line of code. You just click input, calculation, output, and then you can start with your tests or with your production. So this is also to save money, and also to that people who are not educated as a software programmer can use these smart amplifiers. So it makes it very easy. Next slide, please. This is another example here with a multi-channel amplifier doing a test for seats or something else. So we can jump to the next slide, please. This is an example about the interfaces we use. So there is no special software which has to be loaded on a PC or somewhere else. So the operation comes direct from the device, meaning there is a web server inside. You only need a standard Ethernet, which you have on your PC, on your production line, or even with Wi-Fi. This is possible to get a direct access to this unit here, and you can then adjust all parameters. You also see diagnostic information, and you can use it on each device which has a web browser. Either it's a PC, a tablet, or even a smartphone. These web servers are optimized that you always have a good reading and can see all the values on the screen. So this makes it very easy, and because it's an Ethernet-based construction, you can do that not only directly at the device, you can use a factory network or even the internet to make a remote control, and you can directly see what your machine, your production line is doing, where are the errors, what is green and what is red. So this reduces also your time and the money, because you don't have to drive or to fly to your end customer somewhere around the world. You can do it from your home base. So next slide, please. I have an example here. Though we have one unit located in Germany, which is connected to the internet. And if you just click on this demo here, later on after my presentation, you can have direct access and see how things are working. Please be aware that only 2 connections are allowed. So maybe you if you can't connect, other people are already in. Next slide, please. This is an overview about the web server. So we have 3 different entry levels for simple operator, but also for service people and admin, because not everybody could be allowed to change settings, of course. We have values reading. We have also information about scaling, the TEDs, and so on and so on. Let's see if we have a chance to do a little live demo after the presentation here. Next slide, please. As the amplifiers or the smart amplifiers have only one input signal, we also have integrated a ClipX bus where we can connect several units in case if you want to read more signals, like we have seen on the press application, where we have multiple inputs and we have to calculate an average force or an average load if it's a weighing application. This can be done over these internal data bus, where we send values, but also the status from one to other ClipX, and this one now can then do the calculation. And then we have a readout about the field bus or the Ethernet if it goes out to a cloud. Next slide, please. Sorry, one back. So this is to give you an overview. This is actually what the unit is can be set. We have on top, we have the green one, which is an standard Ethernet connection, and therefore we have a lot of drivers available. Beside the internal web server, we have drivers for data acquisition. We also have drivers for third-party software like LabVIEW or other data recording. We also have drivers and DLL for Linux and Windows application in terms that our customers want to do their own visualization. Second one is a yellow one, which is in an analog output. A lot of customers use that as additional monitoring output. And below we have the blue one, which is a field bus based on the standard PLC which are on the market. So all this comes with one hardware, means you can switch it. All these drivers and all these stacks for the field buses are already in. So you can easily switch it via the web server, or you can download the DIQ software via our ClipX website. Next slide, please. I think as a machine builder, you are involved in field bus applications, and I now want to switch a little bit to the next developments which come up. And this is where the jump from the field buses to edge software or to cloud software. Beside the real-time data which we use in a PLC to control the production line in terms of some milliseconds, we also use data which we get out of these measuring change for a predictive service, or for a recording about our yield, our outcome. And then we have new technologies, and I will show you that. Next slide, please. So we have measurement data available in real time, which are very sensitive and which come in a couple of milli or microseconds even. Then we have data not in that speed for holistic, or for let's say for service tasks, or for production tasks or quality tasks. And these data can be stored somewhere on a server or cloud. And therefore, we have new protocols. And our view is that in a couple of years, these interfaces will be work together, that we get one interface. Today, we have to divide it in time sensitive or not so time sensitive, because the holistic data and cloud storage is not that fast today to run a machine, to run a production line in high speed, but it's getting closer and closer. I will show you. Next slide, please. So protocols available for cloud applications nowadays is OPC UA. OPC is a standard coming from the IT, running there on a PC for years, and now it's downgraded, and it's also possible to use that in embedded devices like a measurement chain. So we use the data, that means the measurement values and the calculated data, to control a production line, and we pack that in packages and shift it via these OPC to an OPC client. And there we can put it in a cloud or on a server and run some software to get a predictive maintenance, or even to get a holistic view of our production line out there. Beside that, there are also REST protocols available. These are interfaces or protocols which have less overhead. So the data traffic on these lines is reduced. If you think that we have not only one amplifier in this application, we have a lot of more sensors and actuators there, though this makes sense also to run this. Both use standard Ethernet and TCP/IP lines, so it's not a special update necessary for the production lines or for the server. So it's all in place. We just put the smaller protocols in the devices to send it to the data lake. You will see that in the next slide, please. Next slide. Hello, next slide, please. Thank you. So this is a model behind. You see, it goes, what I marked red here, OPC UA covers the production line, the field devices, the control devices like PLCs, and goes up into the enterprise network, which we have in the general management or in the leader of the production line, and can be then transferred also via internet all around the world. And with UPC UA, you have a direct access drop down to the production line. This is a big advantage of this protocol, and main applications you see on a button is production and maintenance. It's not so used in development, but for us as a machine builder, it's heavily important to have these interfaces on our scope. Next slide, please. Next slide, please. Okay, so this is also the topology which we see here. Further, or a lot of them today are used in field control and management level, but in the future we will see that the intelligence, that the devices, they get more and more intelligent, and then these data have to be collected somewhere in a cloud, and then we get these information out of these cloud technology. I have some examples with me, and you will see how that works. And as I mentioned before, the blue cloud, these communication networks, this is getting more and more faster and more efficient. Also there we will see some updates in the future. There is one standard called TSN, time-sensitive network. That means getting these data over a very fast network, because we have more data, more statistics, more diagnostics, and this is not possible with our field buses today. So therefore we use this standard. Next slide, please. This is an example at the end which I want to show you what we did here in HBM. So we have our own production lines for sensors and amplifiers. We also we set it up with smart sensors and smart electronics. Send it to a cloud, which is a Microsoft Azure cloud, and on top of this cloud we have the software from the company Bosch, which is called Production Performance Monitor, and this software allows us a direct view into our production lines, give us an information if something is running not correctly, is sending tickets to our service people. So this is the whole picture which we did already in our factory, and which do a lot of customers, and which helps you to make it more effective and control more effectively your production line. Next slide, please. So this is an overview picture. What is the business model behind? We took a look at the cloud, but what are the services out of there? Of course, we see service and support. So we have direct access to our service people. The general management can have the analytics, how our production lines are running, how often they are down, where is the problem. We also can run our logistics, because we see when we have to order new raw material. And we also can control our manufacturing, if it's ramping up or coming down, and if there's a need to do an update of the mechanics of the software, whatever. So this is the information we get out of these data. Sorry. And which help us to reduce the costs of our production lines. Next slide, please. This is some, at last, these are some pictures here from our production line. You see, this was very old-fashioned. So there was a printer with a printout of a production temperature curves, in this case, in the line manufacturing load cells. On the picture below, you see we updated them with these smart sensors and smart electronics to read these temperatures permanently. On the right side, you see, actually, this is a screenshot from the software where we see the temperature curves, where we see where something was dropping down, like the cooling system or the heating system, or the moisture or the humidity. So these parameters are read by these smart sensor chains, and then we have directly, as I mentioned, we have a direct access to our service if something has to readjust it, and we also can see if we have to rework something and the outcome, what sensors, what production sensors are available on the next day.
Michael, can you hear me?
Yes.
Michael, I think you are overshooting the time.
Yes, I have the last slide, please. Then I'm ready.
Thank you.
coming to the last slide. We can jump over that. I explained that already. Next slide, please. Okay, this is the conclusion of my presentation. We have seen that production monitoring gets new requirements, and how we can solve it with smart and high accuracy smart sensors and electronics. We use that in production lines, but also in test stands like functional testing, and also calibrating is one part which is necessary to guarantee the quality. All this comes from the HPK sensors and electronics. So this is the end of my presentation. If you have questions, jump into our online boost. And there are my colleagues available waiting for your questions and giving you answers. Thank you very much.
Thank you so much, Michael. That was amazing. Thank you for being here. It was wonderful having you.
Thank you.
I wish you all the best and success with this expo.
Thank you.
So, ladies and gentlemen, I think we're running a little behind schedule, but we're certainly going to cover up for that. It's my honor to now call upon our next speaker, Mr. Sudhir Dembi, the Senior General Manager for Schneider Electric. So our topic would be change from traditional platforms to universal platforms. And we've got Mr. Dembi throwing light on that. Sir, can we have your video on, please? Firstly, I want to thank you for being patient with us. It really means a lot. And over to you, sir, not taking any more of your time. Over to you. Can we unmute yourself, please?
Can I share my screen?
Of course, sir, of course. No, I guess we have the moderator coordinating that, so I'm going to move out. Harpreet, over to you.
Yes, sir. Go ahead. You can share your screen. No problem.
Just see how the network is coming. Oh, okay.
Yeah, perfect. Just put in the slideshow mode.
Yeah, that's okay.
Perfect, sir.
Yeah.
Well, thank you. Thank you all to be here, and thanks Auto Expo team to giving this opportunity to present the story. For the change we're talking about moving from a traditional systems to a universal systems which can be interoperable, portable, and the whole gamut is being unlocked, being discussed due to what we see Industry 4.0 and later on Industry 5.0 evolution which will happen, and what we see today, the gaps what we have. We talk a lot, and we talk a lot about what we are going to give on the platforms of today, what we can achieve. And I would like to give a snapshot what we are talking as Schneider Electric and Aviva as our partner for this for digitization. What we are talking about, so that I can bring up the story about the total universal automation. What we will go ahead with. Is it audio on there?
So all is good. All is good. Yes, Jyoti. Yeah. Yeah. I'm saying in the
Uh, I hope people were able to listen, but one of the feedback was the audio was not enabled. This is our universal automation platform. What we talk about here. Sorry, not universal automation. This is a unified command control center. What we are talking about, giving the total view, end-to-end view for the industry. For any enterprise which is located different places at one time, and you can optimize your resources. You can get all the views what you want along with the asset management features as and 3D modeling also, and digital twin can be also developed on this platform. That's what we wanted to give a message out of. This is what we are talking about. We are talking about industry 4.0 giving us higher level of efficiencies and giving us much more and do much more with lesser resources. That means manpower resources as well as the utilization resources in better way, which are natural resources or the other resources what we have like power and others which are there. So raw material utilization, everything has come into picture to these aspects, and we are able to today do to some extent the digitization of the factories uh, very well, and somewhere we have also failed out there. We are not able to get the right data on the platforms what we want, get it done easily. Sometimes the integration cost right up from the plant floor is much higher than even at what you do at the top end, and sometimes you need to change the controls as well. So this is what we have typically the architecture. Let's this is a Schneider architecture, but today you have different models, different PLCs, different DCSs in your place, and what you see is you need to go back, get the data on the OPC, and then you have to move it out, and you're still dependent on the local, different teams, different setups, and that's what is a difference creation which is happening. We are getting stuck in between. And we want to address these all issues what are coming at the edge control layer. That's what we are talking about, the controls, either the DCS or the PLC platforms. That's what we want. We want to have an open system for the industry. That's about the way forward has to be. That's the reason what we said is let us make a change and move from the traditional architectures to the new setups, make it open. Let's see what has happened of late. COVID has made it accelerate. We were thinking about digital will be 5x, 3x, whatever we're talking. Lot of data points were given, but definitely COVID has changed a lot, and we can see it ourselves. The way we are conducting our business, way we are exhibiting, everything is now digital, and our travels have reduced drastically. So what it goes is new models being set up, new data sets being drawn out, new networking philosophies coming in, and with the 5G coming in, we expect a much bigger efficiencies to come into play, and where we'll have a very fast networking speed. So what it will do, it will also now it will increase the competition. Economic uncertainty will become very sure out there, which is a part of the COVID today itself. We don't know what's going to happen, but competition is going to be. Everybody wants the system today rather than wait for the time for us. We have a very changing variable commodity cost out there. You can see today every day we have a change in petrol prices. Similarly, it happens with any other products as the demand increases. So we have regulations which being deployed now in India. We will have more and more stringent regulations where the adulteration, other pieces will be put on the people out there, on the enterprises. They have to maintain their systems. What we see happening. And definitely there are a lot of advances and generational shift which is going to be, which is very happening out in India, and we are in the forefront of that generational shift, which we have, and we have one of the youngest workforce which would like to see something latest out there, something which is really scalable for tomorrow, changing as it's needed uh, by the markets, and utilizing the best of the technology which are available today, rather than wait for another months and years together for adapting into the industrial world. So what we see is the constraints what we see on the controls of today, and we see a challenge there due to the traditional ways of working of us, and more the psychological ones where we say, okay, this is the one which will work and this is not the one which will work, and we are stuck up with one specific brands or one or two specific brands what we have. But what we see is the need of the hour, what we see is the change, and that's very important. That's a part of the evolution what we had an evolution like that in IT industry as well, and where it has moved to open system platforms of today you talk about anything, you buy hardware, you have you have the software as Windows or something like Unix as you need it. That's not happening in the control world, and we would like to do that. And this is what we want to evolve around, and that's what we want to convey to you. How would we go about it? What has happened so far? If you see the logic controllers, or for the ECS formatter, since I'm talking about logic control, since I'm talking about the Modicon range as a representative here, we put our first PLC in 1968, and thing is that was a time when the first thing evolved, and we were talking about just rail logic, and we had a lot of evolutions, functional evolutions on that, software evolutions out there, but still every product was wedded to its own software platform. And that's what we want to relook at. Do we really continue with that strategy, or we like to have something different, and why we need it? Why it is needed now with the situation what we are in? Every enterprise is under pressure to reduce cost every second day, and you have to go to your shareholders to get more and more profitability. They want to increase the product variance, shorter life cycles. You talk about any of the models out there, after 1 year, 2 year, you have a new model coming of the car. Similarly for the any fast moving consumer goods. And there's a fluctuation demand in energy and raw material pricing. As such, energy is always going to be a variation for us. When you have festive season, we use much more of it, and definitely the production goes up, which is also goes up, and the energy demands increase. And we have a workforce evolution happening in the system. Now on the technology side, things have moved lots man. We were thinking about AI ML, will it come to the industry, but it is a reality today. We never thought we'll have augmented virtual reality things coming up in the industry today. Every second guy is looking for it. We have so a lot of augmented operator advisors to the market. We see a lot of traction happening on the augmented virtual reality out there, and people really interested in it. Data analytics and digital twin is the one thing. Data analytics was anyway there to some extent, what we used to do in a way of APC and asset performance management, in especially in power and oil and gas. But we see this adaptation happening now in the other industries as well. We're talking about CPG asking for it. We're looking at even for the people from the from factories like traditional factories, automotive, and all that. They would also like to look at the data analytics part of that, how the behavior is, where do we find the challenges, so that he can reduce the unplanned downtime. And big change has happened from the system is wireless sensors which have come up, and open source platforming which has come up out there, where lot of innovations are happening, and we are unable to adapt it to our shop floors. So what we have today, this is Industry 4.0 story. We are talking about data analytics. We want cloud computing today. We have automation there as a basic part of jigsaw puzzle, which is pushing the data to the top for us. But is it really ready? What we see here is the openness of the systems what we have today. We had a lot of things happening. Uh, we have moved a big way, I would say, from 1960s to 1990s, the 2000s of today. But still, we have challenges of interoperability and portability. Although we are confirming the IEC 6131-3 standards of programming software, but still we lack that portability. I cannot port from one vendor to another vendor the whole programming software, so that I can utilize something else out there, or something might be better in other Y vendor and which I can use in the X vendor. That is one thing which is a challenging aspects which is coming out. And with this is the inherent design of controllers, which is more towards OT part, not integrating the IT part. So looking at this part, we as a company thought about decoupling the two and making the way for a new way of working, something like the IT people do. Something like you take the hardware, whatever you want, take up the software which is right for you and which could be the one. And we are talking about that kind of platform which is in line with the what OPAF wants, and this is what we are working with OPAF teams out there. So open automation platforms, what we are talking about. So where what do we give here is an new standard to the world out here, which is confirming to a life cycle which is evolving, which is interoperable, portable. You can change that as you want. You can adapt to the latest technologies as you want. So what has happened so far in the OT world is typical life cycles. We're talking about 10 to 40 years of life cycle, still proprietary, real-time cyclic deterministic network, and very low level of C visibility. Whereas IT world is totally different. Every 1 year, 2 year down the line, we are having a new hardware, we are porting it up, we have a new OS operating systems coming up from Windows, and new standards being evolved. And lot of things have changed in IT world as well. Although it was monolith earlier, but now it is totally changed. And where the portability from one system to another, whether if the code is made on Unix, it can be same code can be ported to Windows platform as well. So that's what has happened out there on the IT world. But definitely the life cycles have a reduced life cycle. 3 to 10 years is the life cycle of the IT world. But we always talk about OT IT merger, and somewhere down the line we have to now make it happen. So what do we see in the future out there is software will be the key factor which will be differentiating the market, and people would like to have an open system out here. We see IT OT the convergence which will do, and we will see much more efficiency coming out into that. And definitely with this convergence, what we see brain drain issues are minimized out there, since we are talking about a standardization of the operating systems. We don't need to depend on one X vendor. Only that way we need to know we are defining a standardization of those software platforms across the board, what we want to do here. So what will make it happen? We are talking about the standard which we see is was enabled way back. It is there in the books, and that is called IEC 61499, which really looks to be fitting in for from our perspective. When we look at the market, when we look at the industry, this is a platform which fits in best to the industry needs. What it does is it does not define the programming languages. It can put in the programming languages of IEC 6131-3, which is inside for the coding, and it can use the latest IT languages as well. That's what it brings to the table. And also enables the programming based on asset centricity, which is more of a DCS parlance. We are bringing it to the control level itself, at the PLC level, more asset centric design, and so that you can really integrate it to the IT level easily out there, and inherent connectivity to the IT world. That's what it brings to the table. We are defining here a world which is plug and produce automation system. So we are talking about, you have an automation system. If somebody has made an, like what we have app today for our mobiles, you have some app made for share for your Uh, for a distillation column, which works much better. You have much codes out there which are there. Might be for boiler efficiency that you just plug it into it and it will work. That is the interoperability and the portability we are talking about. You have an app store, you deploy it and have it working. Irrespective of the one who is developing it, he can put the application to this platform. So what we want to do here is we want to work on our controllers. We'll work on the other controllers as well as the standardized off the shelf controllers. What we're talking about, like Raspberry Pi, where we can use the systems and any of the PC based controls as well. Another missing part was the event driven things. What we said, and why do we use the cyclic? Why don't we go for event driven scanning? So it will improve over a lot of bet lot of speed and also have a better utilization of the resources of the controllers and lesser scan times. What we talk about. So what we have is software centric is the what we're talking about. We're talking about software universal automation is the next leap what the industrial automation have to move to. And this is what we want to go ahead as the platform for the future. So I would just show a video what we want to do and how it is good for the industry and what it gives a different view to the market, what it can bring to the table for the better efficiencies and lesser cost. And you're not stuck with one specific vendor for your next generation platforms. You can go for open architected solutions. You can use any of the hardwares to deploy into your factories. But the software can be one common platform what we can provide you with this, which includes the control. We were talking about software as a SCADA, but we're talking about here SCADA plus the control environment, which is hardware agnostic kind of story we want to build up on here. And that's our aim to move the industry towards that kind of thought process. An open system, interoperable system, and portable system. Just giving you a glimpse of what we have on the automation system. This is a try from oversight. I hope uh, you are able to get the v- audio. I think the audio was not visible, so I don't know how I can make this enabled. Do we have any path of making the audio enabled?
Can you play it once again, please? Can you play it once again?
Just a moment.
Yeah. Yeah. You just unshare your screen once. Unshare your screen once.
Okay, just a moment.
Yeah. Okay. Now you press share.
Ah, thank you.
Sudhirji, can you hear me?
Yeah.
Yeah. So when you're sharing,
Got it.
okay.
I've done that. I
Okay.
missed
Okay.
that
Great.
button.
Great. Thank you.
Thanks a lot.
Yeah. Take care.
Is it audible now?
Yes, sir. Go ahead.
Meet EcoStruxure Automation Expert, a new category of software-centric automation for the digital world. Today, automation engineers use many tools to design an industrial automation system. Without a common source of data, they must manually repeat tasks from tool to tool and discipline to discipline. It's not efficient. EcoStruxure Automation Expert creates a complete digital lifecycle for your automation system. Engineers are free to design processes independently of the automation system. Once the design is complete, the engineer deploys the application on the hardware in just a few clicks. Applications are automatically distributed. Any changes can be made with zero automation engineering. EcoStruxure Automation Expert makes it easy to design your automation control system, and you can easily connect a digital representation of an asset to its real-time control. Using this digital twin, testing and adjustments can be conducted in a virtual environment. Commissioning time is reduced. You're up and running faster. Market demands change fast and often. To keep up, manufacturers must be agile, adding and modifying equipment quickly and easily. When market demands drive your plant to its limits, EcoStructure Automation Expert makes it easy to generate additional capacity. Production assets can be added with a simple drag and drop. EcoStructure Automation Expert is a new category of software-centric automation. Bring your operations into the future today. EcoStructure Automation Expert can help you keep up with the speed of doing business in the digital world.
This is so overall what we are driving here is total efficiency of your systems. What we want to bring to the one is interoperability and portability. We want to drive 100% engineering efficiency here, where you can port it to your systems from PNID diagrams, get it inside, get the electrical pieces also involved in it, whatever you need for your options, operations, operational effectiveness, and the future ready. The way we say about the future readiness is this is evergreen platform now. We are using the latest technologies out there where I can port the application codes from one to another. Today, even if the code is being deployed for the next generation software, what the releases which are coming up, I can port the codes out there, or the functionalities can be ported in the lower version of the software as well. What's going to come up, just with enabling the composite objects, what we were bringing into the table, which are basically uh, codes which can be interoperable and portable out here. That's what we have on the total platform, and that's all what I have today for you. Thanks a lot for giving time. Any questions? I can take it now or offline. Thank you.
Thank you so much, Mr. Dembi. I think that's exactly what we get to hear from a gentleman with 30 years plus of experience. Well, we didn't have much time to say anything about Mr. Dembi earlier, but yes, I'd like to take this moment to just mention that with so many years in the industrial automation, he has done his PGD in energy studies from IIT Delhi and is a TUV safety certified engineer. So thank you so much for being here. And yes, for the questions, I think the chat box is open. Do we have any questions for Mr. Dembi?
Lavina, there are no questions as of now.
All right, so I think we'll end it there. Once again, thank you very much, sir. Thank you, ladies and gentlemen.
Thank you. Thank you.
All right, so we'll be taking a short break here and we'll be meeting you again for our next session. Around my schedule, it's 2:25, so we'll see you then. Thank you. All right, that's a little error. Please make note. Our next session is at 1:50, 50, Indian Standard Time. Thank you. प्रेजेंटेशन तो फिर आप सेव करके और प्रेजेंट कर सकते हैं। हाँ ये तो pretty easy रहे और ये Let's check if
अरे ये नहीं दिखा।
एक बार मैं चेक करती हूँ
Stop
अगर
sharing.
आपका वहाँ आ रहा है तो